Today we're going to study two mathematical concepts in one lesson. The first will be geometry, the integration of geometry and probability, otherwise known as geometric probability. And to provide a couple of illustrations of what this actually means, please look at the first page of your handout. You all are familiar with the Malaysian Airlines flight that disappeared in March of 2014, correct? Anyone not hear about that? Well, they're getting ready to resume the search for that aircraft, which mysteriously disappeared off the face of, somewhere on the face of the earth. We just don't know where. With all the technology today, you'd think we'd be able to find that plane. But they're going to concentrate the new search areas about 1,100 miles off the west coast of Australia. It is called the seventh arc of the Indian Ocean. It comprises of 23,000 square miles. One of the tools that they're going to use to try to find the missing airplane is the Bluefin 21, which is an automated underwater vehicle, and it maps the bottom of the ocean floor. So by mapping the bottom of the ocean floor, they hope to identify some things that look like airplane wreckage. The Bluefin 21 can map 56 square miles per day. So think of that. We have a 23,000 square mile area. We have a tool that can map 56 square miles per day. So with that information, we can calculate the probability of finding some airplane wreckage within 1 day, within a week, within a month, and on down the line. The second example I have on the sheet is a little closer to home, literally. And looking at the possibilities for student teaching, I want to concentrate in the Pittsburgh area or the near suburbs like Stowe Rocks, Ambridge, McKeesport, or Emsworth, on down the line. So what I did was I took an image of Pittsburgh and put my house location on it, drew a radius of 10 miles, thinking I should be able to find something in the Pittsburgh School District within 10 miles. So with the information of the 20 by 20 map of Pittsburgh and my 10-mile radius from my house, how do you think we go about calculating the probability that I would get an assignment in that 10-mile radius? You?
The amount of schools within the radius that have what you're looking for, I'm assuming it would be a 7 through 12 map, and then you just take the probability of being present one of them.
That could work. And then looking again at the probability of that, or the area of that circle versus the whole area. So we would get. So if you turn over the page, we have some terms relating to geometry and probability. And before the lesson starts, please read through each of these and indicate whether or not you think they're true or false. After the lesson then, we'll review these again and see if you changed your minds on any of these. So please go through these statements and indicate true or false. Take a couple minutes. So the first one, a figure, circle, a figure that measures 180 degrees. Is that true or false? And the second one, diameter, a segment that connects from the center of a circle to a point on the circle. Just answer true or false for each of these. I won't go through all of them. Just take a minute to do that. Looks like everyone's pretty much finished with the statements. So now we'll proceed to the lesson. Again, we'll circle back to those statements after the lesson. But the objective for the lesson today, again, is to use geometric figures and the concept of area to calculate probability, which is actually state standard 2.7.G.A,